already sharing, right? So
yeah. So that,
yeah. Okay.
Was our class was that kind of
Oh, except the papers. Oh, hi.
yeah.
Oh, that's right. Only if I could.
they did
There we are. All right.
Yeah,
his office
but it
is
doesn't sound
all
like
the same.
some people.
Should we go ahead? Okay, cool. I guess I'll stand. So yeah, always to introduce myself. So my name is Jake Whitehill. I'm one of the research fellows at Harvard's Office of the Vice Provost for Advances in Learning. This is going to be a dual session, and the double feature. So basically, similar talks, both about crowdsourcing explanations, but with kind of different motivations and different focuses. So mine is about crowdsourcing kind of like tutorial videos on, I chose the particular domain of math, kind of middle school math on logarithms, and Joseph will talk about his own stuff. So mine probably lasts about 20 minutes, and then Joseph will take the rest of the time. And especially since we're such a small audience, feel free to interrupt me. My talk is pretty conversational, i.e. rough. But yeah, so my talk is called A Crowdsourcing Approach to Collecting 399 Tutorial Videos on Logarithms. I chose 399 for the title because that's the many I actually crowdsourced. And so I want to describe the motivation for this. So my background is in computer science, and when I was a graduate student, I took part in this data collection effort of collecting this data set of middle school math teachers working with some of their own pupils, tutoring them on logarithms. And the purpose was to understand human-to-human interaction during teaching, especially nonverbal behavior, things like, how does the teacher and the student make facial expressions in relation to each other? Hand gestures, what are they used for? How does the teacher respond to, say, student frustration? Things like that. So that was the motivation of this previous work, which is also, I think, kind of cool. And that project was called SG Math, and it consists of 20 students, 2 middle school math teachers. So each teacher taught 10 students in about a 45-minute tutorial session. There's a pretest and a post-test. And here's kind of an example of what that project was about. So we actually have 4 different cameras. Here I'm only showing 2. We have a wide area camera where we have the teacher and the students, this paper in front of them. There also are 2 cameras pointing at the teacher, one each of the teacher and student. So we actually have also 1 camera overhead pointing at where the student is writing on, right? So it's a very rich data set. These are all synchronized cameras. It's rich, fine-grained. It was annotated for speech, eye gaze, hand gestures, facial expression, and substantially more. So it's a very, very detailed data set, and we hope it's valuable for behavioral research on learning, teaching, and also creating intelligent tutoring systems. And also, it was collected over basically 2 years. An entire sizable NSF grant was devoted pretty much to collecting this data set, and also designing how we're going to do it. It was a big effort. Also, there were 2 grad students and 3 RAs on this project. I was one of the grad students. So it was a big effort. And we think it's an exciting data set, but it also raised a question for me after I left graduate school and I came to where I am now, of could we perhaps find a more efficient way of collecting this kind of data? It depends on what we want to use it for, right? But is it possible to collect a slimmed down version of that ST math data set in a more efficient way? And so that was the inspiration for trying to crowdsource tutorial videos. So for example, if I want to create an intelligent tutoring system that is targeted on teaching kids logarithms, I want to have it could be useful to have a diverse set of explanations to choose from that I can choose. This student is going to receive this explanation, this other student some other explanation. So if that's my main purpose, there has to be a more efficient way of collecting a diverse set of explanations than spending 2 years just getting 20 explanations, over a 2-year time frame. And so the strategy was we're going to sacrifice the richness of one-on-one tutoring. And in a crowdsourcing paradigm, that's not inconceivable, but it's much easier to get just teachers kind of improvising how they would teach a student. And we can see, is that worth anything? Can we get teachers, ordinary people across the web, people on Mechanical Turk, to create explanations? How are they different from each other, even though they're all the same topic, and what is their quality? And also, because since we're going to crowdsource on the web, we also can exploit kind of richer media than a teacher in an ordinary classroom environment can have, where they use typical kind of pen and paper. So we're going to ask people to kind of create a video of their own design. They can use PowerPoint. They can use handwriting on top of a PowerPoint. They can use whatever they want. So there's also an opportunity here to have a richer media experience. Cool. So that's the motivation. And so some potential benefits of having a crowdsourced data set of explanations is that we can potentially personalize which explanation we give to which student. And for example, some videos may suit a student's learning preferences better than others. And also, if you think about peers can also offer to their own peers explanations. Maybe they just learned a topic and now they have a good way of sharing with someone at their own level that also can be powerful. So this is a project, and now this is the current work that I'm actually presenting. That was motivation before. So this is a project that was funded by HILT, Harvard Initiative for Learning and Teaching, and it was about crowdsourcing explanations. And we chose the same topic that we used for that previous project, which is introduction to logarithms. So what is a logarithm? Simple calculations like what is log of 8 base 2? That would be 3, for example. It's an easy enough topic that many people know about logarithms. But it's hard enough that many people either are still kind of stumped by them or they forgot it long ago. So it's kind of, it's arguably kind of a nice middle ground, kind of a sweet spot of what to focus on. So some of the research questions that we are looking at is, the first, is it possible to crowdsource a novel video from scratch from people on the web? What kinds of diversity do we observe in different explanations? And we're asking people to explain the same exact solution, we're asking people to explain how to solve the exact same problems or to introduce the exact same topic. So it's very narrow, but there's still going to be diversity in how people do that. And also, how effective are they in helping students to learn? And we're only kind of going to touch on that last question in this talk. Okay, so we used Mechanical Turk, and in my grad student career, I did a lot of work of image annotation from a kind of machine learning perspective on Turk. But I'm really excited about kind of richer tasks that you can do on Mechanical Turk. This is a really kind of squinched, if that's a word, compressed slide. I'm going to show the actual task in my web browser. Oops, that was it right there. There we are. No, it's not. Exact same web page. So I'm just showing this because it gives a sense of how we describe the task in case you want to do something similar, maybe just use it. So there's a consent form, of course, because the consent form also says what we're going to do. That is relevant. So the key here is you will then be asked to create a novel video in which you explain how to solve a short mathematical exercise. Now here, of course, in the real task, this will be filled in. The content and format of the video are up to you, but the video must address the problem, it must be mathematically correct, of course. For example, the video might contain a screencast showing a blackboard, or you might prefer to talk into the web camera and record a video of your face and voice. A couple people did that as well. Okay. After you create it, you'll upload it to our server. Okay. Okay, so I consent. Let's see. Also a video consent to share in publications and in fact in talks as well. I'm going to consent to this as well. I did a super simplistic and really naive survey. I was just kind of, it's almost like a placeholder. It really very simple questions like how old are you, what is your gender. Conceivably, maybe people of one gender prefer, or learn better from someone of their own gender. I mean, it's a possibility. Oops, I have to answer the questions, otherwise it gives me an error. This publicly available thing that makes it kind of kosher. But I want to give people an idea of what I'm expecting here, and so I'll show you one. I mean, this is not part of our project, but just on the web we found it. Actually, I'm going to skip it because it's not. Anyways, it's a video of a person writing in a little portable whiteboard just up to the screen. So we can give some examples. This is Khan Academy here. We also found it was useful, kind of after a pilot study, to give people really bad, kind of like this. I mean, you can barely read this. This is almost illegible, right? So we showed that this is good. I mean, it's not great, but it's acceptable. This is bad. And we found, I mean, it appeared that this actually had a positive improvement. Okay. And now make the video and upload. So that's just an overview of the human intelligence task, the hits that we put on MTurk. We paid $5 a piece, which is not super cheap. I mean, some people also did multiple videos because they could do up to 18 different explanations. And once you've done one, once you kind of have your style, you know, it becomes much more efficient to do multiple ones. But for that first video, it's more affordable than certainly hiring a teacher. And if we hope that some of the best explanations will be on par and perhaps even for some students better than even expert teachers' videos. So this could still be economically viable. There are 18 different problems. It's actually back to my slides now. Okay, so here are the problems. So this also was drawn from a pretest from that previous study on SD math that I mentioned before. That's fine.
How do any of these
Like or
do they even know what logarithms are?
Apparently, yes. Because some of the videos are actually quite good, and some are mixed, and some are like, what on earth are you talking about? But yeah. I mean,
Did you even mention that in the advertisement? Like,
yes, the sample videos, Khan Academy, it's about math, right? They're all very aware, reminded several times about math. And they're also informed that if they don't produce a correct video, they're not going to get paid.
right.
I mean, remember, this is probably millions of MTurk users all over the world, and they can self-select to know either logs or other logs, right? Yes?
Getting back to his question about whether the audience knows what a logarithm is this aimed at adults or teens or?
Good question. We did not specify. So it was up. That's something that, that's an interesting point that we could have used to steer how they make it. We could have said, make a video as if you're talking to a teenager or a 5-year-old. We didn't say.
But I'm talking about the users. Was his question about whether the people making the video know about logarithms or the people receiving the video?
I thought the former, but
Yeah.
The people making the video.
right.
Well, wouldn't anyone old enough to know logarithms?
This is MIT, right? So not, and remember, this is the special audience. So I would say many people do.
It says, there's this platform assessment that provides online math problems, and when I said I'd like to use some of these problems from middle school math with adults, they said adults won't be able to do it. A lot of adults can't do math as well as middle schoolers.
Yeah, I mean, I teach a stats class at Harvard Med School, and master's and doctoral level students are often like, I sort of remember logs. I mean, it's easy for people to lose that. But I think around here, right, it's like,
I went to high school in 1970 something, and I still remember logs. But I also have a math degree from my.
I mean, I wonder if that's connected.
exactly.
I don't know. Maybe we should do some research on that.
I mean, empirically, we found people on the kind of because we also did some testing of these videos later. Many people did very badly. So there are definitely people who are knowledgeable, definitely people who are not knowledgeable.
Okay.
So these are the problems. Yes.
I just want to add another question about your sample. There's obviously it's a psych literature about how the teaching has an effect on the teacher, right? And there's this natural pool of people who know about logarithms, or people who just took the course, right?
Students.
Yeah, so is there a reason you're trying to harvest like randos off of MTurk instead of like students who've already completed the course? Like, it seems like there's
It's just, this is a direct pipeline to randos, right?
I'm not
I love that.
too serious about your ability to track them.
We now know what mechanical Turk is. It's ready.
I mean, if I had an easy way, a scalable way, where I could, run an experiment, I mean, I would totally go for students. This is so much easier. And it's interesting. It's interesting. It's all right, right? Kind of ordinary people around the world. What can they produce? But I would love to work with that kind of audience. I just don't have immediate access to it.
Right.
Okay, so these are the problems, ranging from the simple calculations to some kind of not too complicated algebraic equations involving logs. Okay, so we did two different. It was a little bit piloted, but 2 different periods of 2 weeks each, more or less, of data collection. And we got about 400 videos almost from 66 unique teachers. It cost about a little bit less than $3,000, including all the commissions that MTurk charges. And now this is not comparable to the SGMath dataset I showed before, and not directly comparable, but the cost comparison here is pretty big. The NSF grant that paid for that entire project was like several $100,000. This is $3 grand, and it's actually more teachers and more explanations, but it's also a different beast. Okay, so this is not to be interpreted literally. This is just a path to a file. I'm going to show you a couple of videos that we actually collected.
Solve for y and y equals 3. Well, log base 10 of 1,000. This is just a constant. They're asking us for what is the exponent we raise 10 to get 1,000. What is the exponent we should put on 10 to get 1,000? So 100, 10 cubed is 1,000. So this whole expression simplifies to just 3. Logarithm means what is the exponent? The exponent is 3. Or step to get y by itself, 3 sides by its coefficient, divide both sides by 3. So y is equal to 1. And that's our final answer.
Okay. So that's one of the videos. That's probably on the better quality side of the 399. Before I test these on new students, I have to kind of confuse them for life, right? It's quite and I would right now it's just me watching it, so it's quite a slow process. I've gone through 145 videos so far, and there's also some really interesting mistakes that people make. This is what's, and I like the fact that it's a combination of using, it's a screencast, right? It's a combination of some computer-generated text, font, along with some kind of screen handwriting. So at least in some simple sense, it makes use of a richer medium than we have just on regular pencil and paper. I found the explanation pretty compelling. That doesn't mean it's actually going to be effective for real students, but I'm working on that right now and I have some results in that at the very end. So that was kind of one of the better videos. Now I'll also show you one of the interesting mistakes. So I'll show you in a second, but in some of these videos, for technical reasons, we crowdsourced as a video file that they uploaded, and others we asked them to do on YouTube. I can talk about that later, but this is one YouTube one. So the mistake that the person makes, strangely enough, they actually get to the right answer because they make 2 mistakes that kind of cancel each other out. This is one of the mistakes. This is just an error. This is not self-correcting. Okay? So they had the expression log 1/4 over log 1/2. And then like, okay, we'll cancel that, right? Cancel the logs, we have 1/4 over 1/2, okay? Which equals itself 1/2. But they actually do another mistake, which is the right answer. It so happens to the original problem. Okay, so I'll show that. It's kind of interesting, I think. Come on. Come on, little web browser. While it's loading, oh, here it is.
Equals
equals, and then you're gonna put log on the other side to even it out, and your superscript over here. And we'll put that in parentheses. Now what you're gonna do is you're going to rewrite the equation with log, and we're gonna divide 1/2 so we can get that x by itself. This x right here, because that's what we're trying to get it or the x. We're going to divide both by log 1/2.
So that's okay, kind of, so far.
Put those in parentheses. So those are going to exit x and bring it down here, and then we're going to put it to the equal sign. Now you also have to do to each side, so we're going to divide log divided by 1/2. So you've got now log 1/4 over log 1/2. Now these logs are going to essentially cancel out, and now you're left with a simple mathematical equation of 1/4 divided a number amount of ways, but on the calculator, if you enter it in, it'll simplify it for you. These two divided by each other are going to equal 2, and
The answer actually was correct, but there was 2 mistakes in sequence that led to them. And let's see. And to give a kind of a glimpse just now in image form, not video, of kind of the diversity of the presentation stuff, and it just kind of film themselves writing. Some people use like a online like paint program to write with the paintbrush. A couple people talked to the camera and held up a piece of paper or used a whiteboard. So actually has some kind of like face interaction. Some people use PowerPoint and just talked over a PowerPoint slide or slides.
You made a PowerPoint?
Yeah, and then they kind of some kind of presentation recorder mode, and they made a video out of it.
How people?
So I mean, occasionally there will be a technical problem, like the person made like a over 100 megabyte file. I was, how do you possibly do that? But someone did, and they're like, I can't upload it. So we had an email conversation, right, to try this. And so some people, I mean, anecdotally, I would say a couple people put in over an hour, maybe even 2 hours on the whole effort. So some people actually find it kind of quite interesting to do this task.
Not everybody's trying to make a living.
Right. So also there was an interesting issue of diversity of language. This is something that kind of stumped me at first. So a number of people who I believe kind of naively were from India, they would say the expression this example, 4 into x. For me, 4 into means like dividing something, but the way they meant it according to their notation was 4 into x, actually 4 times x. And so as an American English speaker, that's when it kind of threw me off at first. But according to Wikipedia, that use of the word into x is common in India.
And Trinidad.
Oh, for real?
Yeah.
Oh, okay, I didn't know, okay.
Yeah.
In terms of pedagogical style, some teachers, when explaining solutions to the problems I showed you before, use kind of they invoke the definition of logarithm. That's how I would do it personally. We're saying, what does log mean? Log means the power to which you raise the base to get the number, the argument of the log, right? So what power do I have to raise 4 to get 4 to the 2b? Well, it's just 2b. That's the exponent. Other people would use more of like a syntactic kind of a computational way of doing it. So they would say, okay, well, we can transform log base 4 of 4 to 2b step by step by using an exponent rule, moving an exponent out front, and then saying, well, whenever you have log base x of x that equals to 1, and then kind of doing the math. So that was kind of 2 general approaches to solving these that we observed. And finally, this is kind of a really hot off the press as of this morning kind of result. So what about effectiveness on actual new students? So of the 145 videos that I watched and verified were correct, if not necessarily the cleanest explanations, I randomly picked 40, and those are my pool of different treatments, if you will, that I randomly assigned to different people who did a pretest on logs, and then they got a video, and then took a post-test, and we can compute post-test minus pretest. There also was a control, kind of a negative control, consisting of a video that I found on YouTube, which is about pi, the number pi. Have you ever heard that before? An unrelated math topic, right? So would we expect to not have any impact on their on their logarithms knowledge? The reason we use that is because the pre and post tests, the problems of those tests, well, they're fixed for every person, but they were drawn from a common pool of problems randomly. But it's possible, in fact, it seems to be the case empirically, that the pretest was a little bit easier than the post-test. So that's why we have this kind of negative control to make sure that any learning gains we observe are not due to just the pretest being too hard. Okay. So we have 40 different randomly picked videos that we crowdsourced, one control that was unrelated to logs. And I want to kind of emphasize the goal of this project is not necessarily to crowdsource only good videos, but at least to get some. If some fraction of them is really good, that itself would be a win, because this is cheaper compared to another way of collecting explanations. So yeah, the probability of receiving a control video, the control video was 0.2, otherwise it was 0.8 divided by 40 for every one of the remaining videos. Okay, so here's the result. So the average learning gains, the post-test score minus the pretest score, was about 5% for the control video. So the post-test was a little bit easier than the pretest, so it seems. But if you look at then like the top 5 best videos that we crowdsourced, look at their average treatment effect, their average learning gains, is about 29%, almost 30%, right? So it's significantly better. In fact, statistically significantly better than that control video that I posted. So this is some evidence that the videos that we crowdsourced actually do have some value. They're not just kind of pretty pictures, but they actually do help students to learn something about logs, and at least at a short time span. Yes?
Just an alternate explanation.
Oh, please.
Other than pretest being easier than post-test, is that because the control video is also about math,
right,
you might be sort of priming the memories that people have when they learn math and when they will have.
That's right. Factors come into play there. That's why we have that. That's right.
Is it not possible as well that just doing the pretest would also get you thinking, you're working through it, and that might be.
It absolutely is possible. And so I wonder if that would have that. I'm not. That's the question that is raised for me, which is great. I'll think about that, but I'm not sure.
I was going to ask about another control. If you just use written word explanations, because those are shown to be super effective, and I feel like the videos, they're not really great quality. And probably like spending hours producing something that would be written in 2 minutes. So
okay, so that is a. That's right. So that's
right, it would be different. Like as another control. It's not the same, so it's not a negative control, but it would be another control in the experiment of, are they learning from just the written example to that standard?
Well, right. So it's that's more about is it worth going to the extra effort of having a video, right?
Yeah.
So that's another interesting domain. The video that I showed you, kind of the good video, was an example that just intuitively I thought offered something in addition to what a paragraph of text will be able to offer. The visual process, the crossing out.
I think that it's useful, and I like videos and using them for learning too, but sometimes it's not necessary. And basics on video.
Yes.
I think people, for example, useful for failing at very basic things. Like the first one was good, but she clicked a lot, and it's just distracting and annoying. The second one, he had the camera facing the wrong way, and he also was shaking the camera the whole time.
The wrong way?
The one that also had the wrong answer rate.
It
was like the wrong way for posting to the internet. It's not horizontal, it's vertical.
Oh, I see.
And so you like have that, and plus shaking it the whole time, and like so even if the content is good, there's all these other distractions.
Yes.
Cognitively, than just.
Yeah, I mean, so this is kind of a good start. Yes, those ways of improving it absolutely exist. And in fact, I didn't know that about YouTube. I was like, oh, this looks good. The shaking is clear, right?
Yeah.
So yes, I mean, the more burden you place on the user to train them,
Right,
the more you're going to increase the charge probably.
yeah.
But they also could improve the quality.
Yeah,
So it's
but those things are easy to fix, like, oh, it's charged. It's okay, but, you know, you'll get better quality things out
Yeah.
of it.
Yeah.
I see a question about the tests. So just like two different things, it's like how many items there are and sort of what's the relationship between like how generalized the questions are in the test versus like the instructions. Sort of mechanically mapping the exact same type of structure of problems or some generalization to
So
even just different transformations. You know?
yeah. So let me go back to the. Where is it?
Oh, and I made this. I'm sorry too.
Where's that?
If I'm making you repeat, I'm sorry.
No. I mean, I'm essentially done anyway, so that's fine. I'm just gonna. Where's my post? Yeah. Where is it? So this also happens to be the question is okay. The Turkers to explain in videos, so that the second batch of people who were not making explanations but receiving them and learning from them or not, they took this exact pretest.
All AT questions?
Yes. Yes. Everyone took the exact same questions. They received a video randomly drawn, as I said, on one of these 18 questions. Of course, it's overlap. I mean, of course, it's kind of bleeding, right? One question is okay. Then they took a post test, which is the same 3 categories of problems, and the problems was randomly drawn from a common pool. So these were 4 samples from a pool of 8 problems, right? So an expectation. Of course,
Every user got the same exact pretest,
Yes.
the same exact post.
Yes, that's right. Yeah.
Just a thing, sort of big picture. This is
The argument, the beginning of it is that this data set has some interest in it, has some application education. There's also, so my background is like machine learning, computer vision. I'm kind of interested in playing around from a computer vision perspective, and like, well, I'm just kind of toying with the idea of can we compress them down in terms of little visual nuggets that come up over and over again. So if your goal is to collect a video data set on the same topic, but to get a diversity of the words that are uttered, of the presentation styles, of the teaching approaches, one way is to go to a classroom and to hire some really great teachers like we did 5-6 years ago and pay a huge amount of money to get a relatively small number of explanations. Another way is to ask people on a Chemical Turk to do it at a fraction of the cost.
right.
Now, is this a way of like, well,
I'm just interested in like, like a dollars or hours per minute of explanation video. Good. Like, so what are the relevant factors that make this really costworthy and what's
well, okay, so
versus, right?
okay, so as Mary, I'm sorry.
Crayon.
So Marion had some suggestions about how to improve the video production quality, and probably there are ways of doing it that are low cost and that have a significant impact. So I didn't do any of those.
Right.
Okay. This is $5. I would, and this is just a guesstimate, but maybe like an average 2.5. Let's say 3 minutes average per video for let's say $3,000 total for 400 times 2 minutes, 1,200 minutes. $3,000 for 1,200 minutes. What's the log of that? Divide 3,000. That's like well, so that's a good point.
Yeah.
No, but so that could in a larger scheme be crowdsourced.
Yeah.
For this project, I had to do by hand because I want to see, I want to catch those things personally. That I'm not worried about. The production.
You're having a course, like, still staff has to interfere and, be spending time on the sorting through them too. So it's not necessarily saving staff time. They will have to sort them through, make sure what's being shared is correct.
No, but remember, this also that can be amortized over a very large scale. Yes?
I'm interested in just the mathematical level of the videos published, and this is actually inspired by your comments that these kind of worthless, which I don't necessarily agree with. But I was thinking, do any of the videos deal with like what is the log of 0, or what is the log of a negative number, or a log of an imaginary number?
So it only came up to the extent that when people were describing laws of logarithms, like log base x of x, right, is always equal to 1. Well, it's equal to 1 when you have log base 0 of 0. I mean, so it kind of came up tangentially in that context. People didn't do like really deep dives on this. Yeah.
And I don't necessarily agree with that. It's got me thinking of log 0.
Yeah, okay. I mean, it didn't come up much in practice.
Okay.
So I've already kind of, I want to make sure, and I didn't actually give enough time.
Well, actually, no, but you know what, actually, Sarah's point out, we're having a really interesting discussion. I mean, I worked in some office shape where people always doing